Alright, hello class. Today we are going to start talking about a new part of the conservation of mass unit, and we're going to be digging in deep with physical and chemical changes. So I'm going to make sure that you remember the overall standard of the unit that we're working on, and it's that the properties of matter are determined by the arrangement of atoms. So far we have studied atoms, and we have studied the periodic table of elements, and we've learned that everything that exists is made up from elements off the periodic table in some combination. We also currently are working on the I can statement. It's a pretty hefty one. It says, I can explain the law of conservation of mass by showing how the total mass of substances mixed together won't change, while their properties, physical or chemical properties, may or may not. Alright, so let's dig in and let's talk about physical changes. You have two papers in your notebook. One is physical change and one is for chemical change. So as you're taking notes here this evening, I want you to make sure that you record important information in the correct boxes of the chart. Right now we're going to define both of them and also start giving examples of them. So that would be the top left box and the bottom left box that you want to fill in. A physical change alters the form or appearance of a substance, but it does not create a new substance or a different substance. That only happens during a chemical change, which we're going to talk about in a second. When you hear words, verbs used to describe what's being done to a substance, such as bending, crushing, breaking, cutting, melting, freezing, boiling, etc., none of those would indicate that a new substance is going to be made in the process of doing those things. So therefore, a physical change would be occurring. We're only changing the form of or the appearance of the substance. Chemical change has a synonym. It's chemical reaction. And we have actually used the word reaction or reactivity in the past few days. If you recall, metals are very reactive, and so therefore they undergo chemical changes often when combined with other elements on the periodic table. When a chemical change occurs, a new substance is created, and this occurs when bonds between atoms break and new bonds form, and this would be the creation of a new one. Moving on, we're going to talk about some clues that would help you to tell that a chemical change is occurring. Observations during a reaction you might notice would be bubbles forming in the substances after they've been mixed, a temperature change, meaning it could be an endothermic chemical reaction or an exothermic chemical reaction. An endothermic chemical reaction means that heat energy is being absorbed into the substance. In an exothermic reaction, the heat is actually leaving the substances, so heat moving towards the air or the substance around the chemical reaction. Another new vocab word might be the word precipitate or precipitant. It means that a solid is forming. So if you mix two liquids together and you see solid forming within the liquids, that would be a precipitate. So that means something has changed from liquid form to solid form. Another thing that could happen is you have an odor form where before there was no odor noticeable. And the same thing with the color, that the substances when mixed change color altogether, so neither substance is the same color that it was prior to the joining of the substances. Changes that can be, or observations that you can make after a reaction occurs, is that when you test the physical properties, that they are different. So before, it might have been a shiny object. For example, iron is shiny. However, when it reacts with oxygen, rust is formed. Rust is not shiny. So therefore, it went from a shiny metal to a dull, different colored metal. So that would be 2 indicators right there. Also, you might have an odor different from before. State of matter at room temperature might be different. Maybe before it was a liquid and now it's a solid at room temperature. The freezing or melting point, which means if you try to freeze the substance or melt the substance, depending on what you're starting with, that it would happen at a different temperature than before. Boiling point as well might be different, and the texture might be different. Maybe before it was smooth, like as in metal before it's rusted, but then when the metal is rusted, it is more rough and flaky. So those are some clues to tell you that it is a chemical reaction. Now that we've talked about the definition and some important facts, let's move on now to talk about examples. Here we have 6 items, and let's kind of go through these and see what you think, and I would like you to write them on your paper, whichever one you think it belongs in, under examples. Frying eggs. If you think that is a chemical change, write it under chemical change examples and include the clue that clued you in. If you think it's a physical change, write frying eggs on the other Freer model under examples. Toast. Is this a physical or chemical change? Just write what you think. We'll check it later. Cracking eggs. Physical or chemical? Slicing bread. Physical or chemical? Lighting a match. Physical or chemical? And last but not least, roasting marshmallows. Now, what I would also like you to do is to do a little research on your own and try to add a couple more examples that are not on the screen to both your physical change Freer model and your chemical change Freer model. When you come to class later this week, we will take time to draw some illustrations from the labs that you did this week and explain what clues we have to explain whether it's a chemical change or physical change. We will also take time to check your examples and possibly add on some non-examples into the box after we have checked the examples. So I hope this is helpful in studying chemical and physical changes, and I'll see you later.